Hello everyone, I hope you all are doing great. So in today's video, we are going to discuss on queues, which is an abstract data type, somewhat similar like stack, uh, but unlike stack, where we can use only the top element, like we discussed in the previous video, we can perform the data operations only at one end. Hmm? Mainly we call it as the top element of the stack. And the operations are last in, first out, right? We call it as LIFO. Whereas in queues, we can perform the data operation at both the ends. So we can perform the data operation at both the ends. One end, we can perform the insertion, and the other end, we can perform the deletion. So here the end where we are performing the insertion of the element, we call it mainly as enqueue. Oh, sorry. And the end where we are deleting, we say dequeue. And other point to note is for stacks, we have last in first out, whereas for queue it is first in first out. So what we mean by this is the data item saved first will be accessed first. Let's try to understand by using a real world application. Okay, so here I'm going to talk on ticket building. So this is my ticket building, and people are standing in queue to book ticket for a function. So already we have 3 people in the queue and one more person is also joining. So the person will be coming here. So this is in insertion. So one more person entering the queue. So let me just change the color of the person. Okay. So one new person has joined the queue, and we call this operation as enqueue. And we always do the insertion at rear point, right? Now this person is able, who is standing at the front of the queue, it is done with its booking. So this person got the booking of the function and he will leave the queue, right? So this is DQ. Now this person will come to the front of the queue, and similarly, once the ticket is booked for this person, he will also leave the queue. Then this person will be coming to the front of the queue. Now, in future, if any more persons want to book the tickets, then they will be getting added at rear point. Okay. So this is how a queue operation happens. We have one end front where the deletion happens. We have another end as rear where the insertion happens. Deletion, we call it as DQ operation, and insertion is NQ. Let's do an hands-on activity. So I'm going to define a class as my queue. And here I'm going to declare the variables front, rear, and the size. Coming to the public declaration of the class. So here we are going to perform the queue implementation by using arrays, and you can also try the implementation of the queue by using linked list concept. So in this example, we are going to use arrays, and I'm going to declare the size as 10. I'm going to define the default constructor where I'm going to initialize the front as -1 and my rear as -1, the base conditions. So we will be performing the key operations, that is enqueue, dequeue, and I will create one function to display the queue. So boolean, I'm going to perform enqueue and data. Then we want to perform a dequeue operation as well. Then a function named display to display the entire queue. So we're done with the definition of the class. Now let's declare all the functions one by one. So return type, name of the class, name of the function, parameter. Okay. So here the first check is if my rear is less than the size of the array, because we have declared the size as 10. Otherwise, what it is overflow condition, like we mentioned in stack implementation as well. We have reached the entire size. We cannot insert more elements to the queue. So just printing overflow and I'm returning false. Now if there is a room to insert an element, so I just need to increment rear and I'm going to put the data. Return true. Now okay, so if this is the first element, so I know, okay, I am able to insert the first element at array 0, but I have not, but my front is still initialized to -1, which is wrong, right? My front should also point to the first element because the first element would be deleted. So here I have to put one more condition, that is if my front is equal to -1, if the queue is empty, at that time, if I'm getting a new element to be inserted to the queue, I should initialize my front to 0. That newly added element in the queue will be my first element as well for the deletion. Okay, moving on to the next function definition, return type, class name, function name. So here I'm going to check if my front is equal to -1 or my front is greater than rear. It means queue is empty. That is underflow condition. So I cannot delete any element from the queue. So I'm going to return 0. Otherwise, we do have element in the queue. So I'm just going to declare a temp variable, and in else I'm going to assign the front element to my temp variable, and I'm going to increment front. So return 10. All right, we are good with the pop operation. Moving on to display, return type, class name, function name. So here I'm going to use for loop, and I equal to from front and I less than equal to rear I plus plus. I'm just printing the elements. Okay, Coming to the main, I'm just going to create an object. The class is my queue. Going to call enqueue function. Inserting the data is 12. And object name dot function name. Setting the data as 23. My queue dot calling the enqueue function. Setting the data. Okay, so we have performed enqueue for 3 elements. Let's call display function to see what all elements are there in the queue. So my queue dot display. Let's run the program. Okay, so we are good with insertion, that is enqueue operation with 3 elements. Now if I'm going to perform the dequeue operation, so in dequeue we are returning what we are removing from the queue. So I'm just going to take that element in X, queue dot, sorry, I'm going to call the queue. So just printing the deleted element. So the element removed is X. And after that, let's print the remaining queue. Okay, so just I can call the display function to check now what is the new queue after the removal of the element from the front location. So I inserted 12, 23, 56. After the insertion of these 3 elements, I'm removing the element at the front. So my front element is 12, right? I have removed the element 12. After that, my front moves to 23, and I'm displaying the remaining queue, that is 23 and 56. Okay, so I hope you would be comfortable with the basic operation in queue. Please try performing the other operation, like just printing the front element, or printing how to just get the element at the rear point. And if you want to cover more problem solving and questions that companies mainly ask for queue data structure, please mention in the comment section. I would like to cover those topics as well. I hope you like the video. Have a good day.